In order to find dy dx, we're going to have to use implicit differentiation. So let's take it term by term. First, this is the product rule. So we're going to need 1 d2 plus 2 d1, and that's going to be 2x dx. For the next term, just differentiate that, so we'll get negative 3 dx. And on the other side of the equal sign, it'd be just 2 dy. The next thing we're going to want to do is collect all the dy's on one side and the dx's on the other. So my dy's, I got this x squared dy, and I got this 2 dy, which I'll bring over to the other side by subtracting. And that's all my dy's. Now, for the dx's, I'm going to subtract both of them over to the other side of the equal sign. So that would be plus 3 and minus 2xy. Those are all my dx's. Now, just a little bit more algebra. I'll divide both sides by the dx to get that off of here. And then I'll divide both sides by this x squared minus 2. And that'll get these ones to cancel. So then we'll have our answer of dy dx is equal to 3 minus 2xy over x squared minus 2. Once we have that, we can move on to the next part where it asks, when does this curve have a vertical tangent line? Well, all this describes the slopes of all of the tangent lines. And when that's going to be vertical is when that slope is undefined. So that means the denominator, x squared minus 2, would have to equal 0. So we just solve for x, and we get that x is equal to plus or minus the square root of 2.